Hello there. Today we're going to be talking about transformations of functions. And what that refers to is if we start with one of the basic parent functions that we talked about last time, what can we do to it to get a graph that's the same basic shape, but maybe shifted up or down or right or left, maybe stretched or shrunk and squished down, or flipped upside down. So we're taking functions like these as our starting point and then looking at variations on these. So, for example, suppose we start with our friend the squaring function. Takes whatever number you give it, gives you that number squared. The graph looks like this, of course. Here are some of the points on the graph. Now, what do you think would happen to this graph if instead of just y equaling x squared, we had y equal to x squared plus 2? So what that does to the y coordinates is it makes them all too bigger than they used to be. The point where y used to be 4, y is now 6. If y used to be 1, y is now 3. If y used to be 0, y is now 2. So in terms of the graph, that means that every point on the graph has 2 added to its y coordinate, and that shifts the whole thing up 2 spaces. So we used to have a point at 0, 0. Now we have one at 0, 2. We used to have a point at 1, 1. Now we have a point up at 1, 3. We used to have a point at 2, 4. Now it's up at 2, 6. So all the y coordinates got 2 higher than they used to be. What about x squared minus 4? What would that look like? So now all the y coordinates are 4 less than what they used to be. They've had 4 subtracted from them. And so what does that do to all the points that make up the graph? It shifts them all down 4 spaces. Where y used to be 0, now y is negative 4. Where y used to be 1, y is now negative 3. Where y used to be 4, y is now 0, and so on. Now what about if we replace x with x minus 5? So what used to be happening to x is now happening to x minus 5. It's x minus 5 that's getting squared. So whatever x used to be, now we're doing that same thing to x minus 5. And so we have all the same y coordinates. There's still a point where y is 0. There are points where y is 1 and 4 and 9 and 16. But they've been shifted over. They occur with different x's. What used to happen when x was 0 is now happening when x minus 5 is 0, so x itself would have to be 5. What used to happen when x was 1 is now happening when x is 6. What used to happen when x is 2 is now happening when x is 7. So that means that the whole graph has been shifted over 5 spaces to the right. The point that used to be at 0, 0 is now at 5, 0, because x itself would have to be 5 so that the x minus 5 that we're squaring turns out to be 0. So if you've got a formula for a function and you replace x with x minus 5, that shifts the graph over 5 spaces to the right. And what if we replaced x with x plus 2? So now what used to be happening when x is 0 is now happening when x is negative 2, because that's what would make x plus 2 come out to be 0. What used to be happening when x was 1 is now happening when x is negative 1, because that's what makes the x plus 2 come out to be 1. And so the whole thing gets shifted over 2 spaces to the left. The point that used to be at 0, 0 is now at -2, 0, because x has to be -2 in order for x plus 2 to be 0. So this summarizes these kinds of vertical and horizontal shifts that we've been talking about. If you take a function that you know what the graph looks like, and you keep that same formula, but then you add a number to the end, that shifts the graph up that many units. If you subtract a number on the end, that shifts down that many units. If you replace x in the formula for a function with x minus some number, then that shifts the graph that many units to the right. And if you replace x with x plus some number, that shifts the graph that many units to the left. The shape stays exactly the same. We're just shifting everything up or down by that many spaces, or right or left that many spaces. And we can combine both kinds of shifting in the same graph. So we can have y equals x minus 5 squared plus 3. What do you think that's going to look like? So our starting point is just x squared. It looks like that in terms of what shape it is. But instead of x, we have x minus 5. So that shifts everything 5 units to the right. And then the plus 3 on the end shifts everything up 3. So starting from just the graph of x squared, we can shift 5 right and 3 up to get the graph of this function, y equals x minus 5 squared plus 3. And what about this one? Y equals x plus 2 squared minus 4. Compared to just x squared, how would this be shifted? Left 2 and down 4. So the graph looks like this. The point that used to be at 0, 0, that's the bottom point, the vertex of the parabola, is now 2 spaces to the left and 4 spaces down from there at -2, -4. And what about this one? Y equals the absolute value of x plus 6 minus 2. So here our starting point, our parent function, isn't x squared, it's the absolute value of x. So do you remember what that looks like? That was one of the basic functions we looked at in the last section. It's got that V-shaped graph like this. So our equation is going to have the same shape graph, but it's going to be shifted over 6 spaces to the left and 2 spaces down, like this. So now the point of the V that used to be at 0, 0 is now over here at -6, -2. And everything's the same relative to that. Now going back to x squared, what do you think would happen to the graph if we stuck a 2 in front of it? So it's 2 times x squared. We're not adding anything, we're multiplying by 2. So all the y coordinates are going to be 2 times whatever they used to be when we were just looking at x squared. Where they used to be 0, they're still 0. But if y used to be 1, now it's 2. If y used to be 4, now it's 8. If y used to be 9, now it's 18. So what happens is that all the points on the graph have their y coordinates twice as big as they used to be, which means that the points are twice as far up above the x-axis. Where we used to be 1 space up, now we're 2 spaces up. Where we used to be 4 spaces up, now we're 8 spaces up. Where we used to be 0 spaces up, we're still 0 spaces up. So the whole thing got vertically stretched by a factor of 2. If we had y equals 3 times x squared, all the y coordinates would be 3 times as big, and the whole thing would be stretched vertically by a factor of 3, which makes it even skinnier and narrower. If the number out in front is 1/4, y equals 1/4 x squared, now the y coordinates are only 1/4 as big, and things kind of get flattened out. All the points are only 1/4 as far up as they used to be. Instead of y being 1, y is 1/4. Instead of y being 4, now y is 1/4 of that, which is 1. And what if the coefficient was -1? Y equals -1 times x squared, or just negative x squared. Remember, that means you square first, and then you take the negative of that. So now all the y coordinates that used to be positive are now negative. Where y used to be 1, now it's -1. Where y used to be up at 4, now it's down at -4. So the whole thing gets flipped upside down. It gets reflected across the x-axis. However far up above the x-axis we used to be, now we're that far down below it. So if we stick a minus sign in front of a function, if we take the opposite or the negative of that function, the graph gets flipped upside down. It gets reflected across the x-axis. Points that used to be up above the x-axis are down below it, and if we had points that were down below the x-axis, they would end up above it. And if we replaced x with -x, that would reflect everything the other way, across the y-axis. So for example, if we start with the square root function, y equals the square root of x, making it y equals negative square root of x, so we're multiplying the whole thing by -1, sticking a minus sign in front of the whole thing, that reflects it across the x-axis. If we replace the x with -x, so that we're talking about y equals the square root of -x, that reflects the graph across the y-axis. So points that used to be over here on the right are now over here on the left. Here we see the graph of y equals 1 over x squared plus 1. I'm just giving you this one. This is what that graph looks like. But what would it look like if we took this function, 1 over x squared plus 1, and just multiplied it by 4? So we had y equals 4 times 1, or just 4 over x squared plus 1. The graph would be stretched vertically by a factor of 4. All the y coordinates are 4 times what they used to be, so all the points are 4 times as far up above the x-axis, like this. And what if we took our 1 over x squared plus 1 and we multiplied by -1? We just made it negative. Like y equals -1 over x squared plus 1. What would the graph look like? Like this. It gets reflected across the x-axis, flipped upside down. Now here we see a graph of a function that I'm just calling f of x. It comes down, it's a point at -2, 0, comes up to 0, 4, goes down here. If this is f of x, and I make a new function that's f of x minus h plus k, changing the h is going to shift everything horizontally. So the y coordinates stay the same. For these 2 points, they're 0 and 4. But the x coordinates get changed. They get added to or subtracted from. If I shift things vertically by adding a number k on the end, now it's the y coordinates that are changing. They're getting added to or subtracted from. And if I multiply by a stretching factor, now the y coordinates are getting multiplied by that stretching factor.